Welcome back to another video in the series of the videos for Numeric Practicum 2021-22. So in this video I do have a fun challenge for you guys, and that is basically we want to take the execution time of our CPP program as a performance metric. So how are we going to measure the execution time of our CPP program? So that I will show you in a second. So let's open Chrome and we search for CPP reference. The first thing which shows up, we select it. Here we do have date and time. When you click on it, you will see that in CPP we have this std chrono library. Completely in the end, we have a very simple example, just like this one, of how one can use this library to measure the elapsed time. For example, in this case, it was 1.8 seconds. And so the first things first, here you include first the chrono library. You have your function. In this case, it is a Fibonacci function. It is a recursive function. And then in the main function, you will call, actually you make a starting point, and then you call your function, your Fibonacci function, with the argument of 42. And after the execution of this function, you call your endpoint, and your duration would be basically the end minus the start. And this will be your elapsed time, which you can access it with this .count to print it to the console. Okay. So we're going to use basically the same principle, but with the difference that we're not going to use the steady clock. You can also see it here. Steady clock, the second one, it is a monotonic clock that will never be adjusted, but we're going to use this variation, the third one, which is high resolution clock, the clock with the shortest tick period available. Okay, without further ado, let's jump into our code. I hope that you remember we had this test.cpp, which was basically trying to solve a very simple set of coupled ordinary differential equations, namely dx over dt, which was x plus 2y, and dy over dt, which was 3x plus 2y. And we tried to solve this with fourth order Runge-Kutta for coupled system of ordinary differential equations. But we don't want to mess with this one, so we make a copy of that. So we say copy test.cpp into test1.cpp, and we try to edit this version. Whoops, that was a typo. So first things first, we include the chrono library. Then we need to put a starting time for our measurement. So we say auto start, and then we say std chrono and high resolution clock, and then you will say now, right? So now I noticed one thing. If I put my starting point here, would it be wise to put it actually on line number 19 or not? Because immediately after this line, I'm trying to let's say read some value from the user. And if the user takes his time and thinks for 20 minutes or so on, this will be counted as my execution time. So maybe it is better to take this line and put it directly after taking the value of the number of iterations from the user. So this will be my starting time. Then I construct my solution vectors, I make my initial conditions, I solve Runge-Kutta and so on, and then I print the results to the screen. And here it is time to say the ending point. And after that, we want to print the difference, right? The duration. And that is with std cout, let's say execution time is how much? How much is that? We say std chrono, and then we say duration cast. We can cast it into std chrono, and then you can use seconds, you can use milliseconds, microseconds, nanoseconds, and so on. But since my program is very simple, it is maybe better to use milliseconds, right? But I need to tell that I want the difference between the end and start. And I also, we saw also here that we need to use this count. So we say dot count function, and then we can also put a millisecond, just a space and then a millisecond. And then we, of course, we say end line as well. So this seems to be okay, or maybe not okay, because if I want to get some good values, or let's say some long values, I need to say, I don't know, 10,000, 1 million, or 10 million, and so on. So printing those 1 million or 10 million elements of the vectors would be very, very nonsense to the console. So what I want to do is to just comment out lines 38 until 5 lines below. So we just comment these lines. Okay. Now we do have everything ready. We have already included this chrono library. We have our starting time here. And then we have, after our function execution, we have our ending time. And then we have our execution time here in milliseconds. So let's ask the opinion of the compiler whether it is okay or not. And we say G++, then test 1, of course, and the output, we call it as, I don't know, output maybe. And we don't forget to put this std of C++11. Okay, we didn't have any warnings or any errors. That's a good sign probably. And now I want to use, for example, I don't know, 100,000 maybe. Okay, that took 17 milliseconds. Of course, in your cases, that would be much, much more, because in my case, it is just solution of a very, very simple, basically two coupled ordinary differential equation of very, very simple type. Now we can try it maybe with more values. Whoops. Let's say this is 100,000, a million. A million takes 77 milliseconds. Let's go even higher. Let's go with, that is a million, that is 10 million, and that is 100 million maybe. Okay, this is probably considerable. Okay, this was 6,000 milliseconds, which is basically 6.1 seconds. Okay, so I hope this video is helpful to you guys. But also, before we close this session, I want to tell you a very important point, and that is this is not very absolute. In other words, it depends also on the hardware that you are trying to execute your code on. And I know that you have, like, everybody has a different PC, or I don't know, a laptop or so. And this execution time, then it is not very accurate if you want to compare it exactly how different groups are standing against each other. So a good idea is, maybe if you have access to BV unicluster, you can try it on the cluster of the KIT, and then we can say, yes, we have tried to test our code on the same piece of hardware. Otherwise, I guess you don't have probably access to BV unicluster, but it is fine. Still, it will be a performance metric for yourself. It will be a performance metric for yourself. You know how much time is spent on the execution of your program. Okay, I hope it helps, and stay safe.